So now it involves two vectors. So what you need to do is go ahead and find the component form of each vector and add them. Add the x's and y's to get your resultant vector, and from there, you're going to find the direction and the speed. So number 2, a plane is headed due east, meaning what? To east. So that's an easy one. You don't have to do sine and cosine to find x and y. We already know this will be 500 for x. What will be its y? 0. So whenever you have two vectors adding, make a table. So here's my x and y. And my first vector looks like this. So without plugging into sine and cosine, I already know my x is what? 500. And y is 0. But would they always give you one this easy? No, but this is our first question. That's why I put an easy one. The second one, it says the wind is blowing towards northeast at 100 miles per hour. Whenever you say northeast or southeast, if they don't say a direction, the measurement of an angle, it will be always right in the middle. So it will be 45 degrees. So where is northeast? Right here, right? So here, right in the middle. If they said 30, then this will be 30. But if they don't say any measure, it will be always 45. So this is 45. And the speed was 100 miles per hour. So obviously it has to be much shorter than the first one if you want to draw in scale. But it doesn't really matter because we are going to find their x and y components separately. So maybe like this. So 10. So now your vector looks like this. 100. Yeah, 100. So here's 100 at 45. Again, on the first quadrant, so you don't have to worry about sign. So what do? To find its x, it is the magnitude times cosine of 45. Y, magnitude times sine of 45 degrees. So it's 100 times root 2 over 2, but we need decimal answers, so let's just put into the calculator. So 100 times cosine of 45, 100 times sine of 45. So they are the same, 70.711. So 70.711, 70.711. So now, what are we doing? We are looking for the sum of these two vectors, right? So if you use a tip-to-tail method, your vector will be somewhere over here, right? Tip to this over here, tail. So we are looking for this resultant vector. How do you find it? By adding the x's together and y's together. So I can call this vector plane. This is vector wind. Now we are looking for vector plane plus vector wind. So 500 plus 70.711 is 570.711. 0 plus 70.711 is 70.711. So this is a component form of your resultant vector, which will be somewhere here, right? 570.711. And this, your y is 70.711. So if they just ask for a component form of a resultant vector, we are done. But what is it asking us to do? Find the speed, meaning its magnitude, and you have to find the direction. Usually the magnitude is easier. Why? What do you do to find the magnitude? So magnitude of vector p plus the wind is what? Square root of x squared plus y squared. So 570.711 squared plus 70.711 squared, which will be, so don't try to do everything at once. Find the square, sum of each square. So I get that. And what do? Second, x squared square root of that answer. Second negative to copy it. So I get 575.075. What? What was its unit? Miles per hour. So as you can see, the airplane flying for 500 miles per hour. Oh, the wind is kind of blowing in the same direction, so it goes actually faster. How nice. So what's the next question now? They want to know which direction their airplane is heading. So first quadrant, nice and easy. Why? The theta that you're going to find is the direction, because direction is from the positive x-axis going counterclockwise, right? So what do you do to find the theta? It is what? Arctangent of your y over x. So again, plug into the calculator. 70.711 divided by 570.711. Press enter, and then you take the inverse of tangent. So I get 7.063. 7.063 degrees of what? Direction. Are we done? What if the question asks you to find the angle measure of bearing? What would you do? Yeah, it's this angle. This is the bearing, right? So you will do 90 minus that to get that angle of bearing. So read questions here. Yeah, so how do you guys like it? This one wasn't too bad because the first vector was pretty easy to find. But for your homework and the question that we're going to do tomorrow, you have to do all this for the first vector as well.